Hello, guys. Good afternoon, good morning, whenever you are watching this particular video. Welcome to the class. My name is Green Abayomi, but you can just simply call me Green, and I'm your physics tutor for the day. Yeah, so you're welcome to Tuteria. Tuteria is so generous to organize these particular free classes for you guys so that you can learn. We are so passionate about getting the best out of you guys, and you are just in the right place. Our program is starting very soon, starting next week proper. But then these classes are just to prepare you ahead of what to expect from what we have for you guys. And trust me, you don't want to miss the program at all because it's a full package. We are starting from January to the end of what's it called? To the end of the whole program, to the end of March till you start your exam properly. So it's not as if we are just doing one topic or we are doing just two topics. We are covering the entire syllabus. So these classes we are having this period is just for you to be familiar with our faces. I know some of you have been seeing our social media post around, and you don't even know what this person looks like in a proper class. Here I am with you. I am Green, and I'm your physics tutor for the day and also for this program. So basically, I term this class the dope class, dope classes, basically. So for the next couple of days, we are going to be looking at several concepts in dynamics, optics, photoelectric effect, as well as electrostatics. Of course, I'm not going to be talking about everything in these topics, but then I'm going to be showing you some important tricks and important shortcuts you can use to solve problems without wasting time. Because I believe you should know from the classes you've attended, the chemistry class, even the English language class, you should understand that UTME physics or UTME any subject at all requires speed, accuracy, and your ability to think very fast. You can't afford to be very slow while you are trying to answer questions. So you must be very fast and you must be accurate. You are going to be encountering 40 questions in physics, and it's possible to get 90. It's not something that has not been done before. In fact, we've had a student that have gotten 98 over 100 in physics. So there's nothing impossible. Just follow the right path. That's just what I would say, and we can progress together. So today we are going to be starting with dynamics. It's not just one class, like I said. So just follow the process with me. Tomorrow we continue again with optics, like that. So dynamics will be our first guide today. And if you have any question along the way, you can always go to my social media platforms, be it Instagram, TikTok, even X, and also on YouTube. You can drop your question for me. I'm going to do justice to those questions. So before we talk about dynamics, of course, dynamics is under a very important guy in physics called mechanics. Mechanics is a branch of physics that deals with the study of motion of objects, study of motion of systems, whether it is a big system or a small system. When we say system, we are talking about objects. So if I want to study the motion of a ball, I kick a ball, the ball is in air. I want to describe, what is the position of that ball at a particular time? What will be the kinetic energy of that ball? Then I'm talking about mechanics. It is a study of motion. But it's not just something that you can see, because physics is not just about the study of things that are visible to the physical eye. Physics is the study of nature. Everything in nature is just what physics is all about. So that means that mechanics is not just the study of things that are visible to the human eye. We can also study the motion of objects that are microscopic. Body of knowledge in physics is still under mechanics. So mechanics generally is the study of motion of objects, whether it is microscopic or macroscopic, meaning whether it is a small object or a very big one. Now, so we know what mechanics is all about. So, but then what is now dynamics? So we understand that mechanics is the study of motion of objects, but then dynamics is now what? So if I have an object that is moving, why exactly do these objects move? What is making them to move the way they do? And that aspect, that body of knowledge, is where dynamics is coming in. So we have different aspects of mechanics. We have what we call statics, we have dynamics, we have kinetics, we have kinematics, and so on and so forth. Now, when we are interested in what is really causing that motion of that object, if a body is moving from your primary school or your SS1 or thereabout, you were taught motion. And if you can remember very well, we explained that the cause of motion is force. So that means that dynamics is that aspect of mechanics where we are not only interested in the motion of that object, but we are also interested in studying what is causing that motion and the effect of that cause. So that means that everything we are going to be discussing in dynamics, we have to do with the concept of force, which is that agent that is actually causing motion here. So that is what we are discussing. So dynamics is the aspect of mechanics that involves the study of the motion of objects as well as the cause of that motion, meaning force, which is the cause of the motion. Now, the subject of dynamics is based on Mr. Newton, Sir Isaac Newton. So there is this, we have what we call the Newton's laws of motion. Of course, this general concept is still about motion. So to understand the concept of dynamics, we need to understand what Sir Isaac Newton said about motion. So Newton's laws of motion is like the foundational law. They are the foundational laws that actually help us to understand the entirety of dynamics. So what are the Newton's laws of motion? Of course, you should know that we have 3 Newton laws of motion. We have 3 of them. We have the first law, we have the second law, and we have the third law. And these 3 guys are all talking about force. The 3 guys are all describing force. Now, we're going to be solving questions today, and you are going to realize that all of these questions that we are going to be solving are all based on these 3 laws of motion. The first law, the second law, as well as the third law of motion. So what is the first law of motion? Let me go down. So the first law of motion, this is just the first law of motion in my own, in the summary. First law of motion is just saying F net will be 0 and A net will be equal to 0. This is just basically the first law of motion. Yes, once you understand this, you will know what the first law of motion is all about. So what is this? What is this saying? Of course, from your secondary school, you have been exposed to the laws of motion already. And the first law of motion states that a body will continue at rest, or if it is in motion, it will continue with uniform velocity unless there is a net external force that is acting on it. What are we saying? We are saying that if I have a ball or a block on this platform here, this is a block on this platform here, this block will remain here. So the body here will remain at rest. Now, there is a misconception about this first law. Most students usually believe that when we say a body is at rest or a body is in uniform velocity, it means that there is no force acting on it. No. Look at what I wrote here. First law is saying the net force is 0. So if a box is here on this horizontal surface here, there are forces acting on this block. But then these forces, when they balance each other, it now means that the body will remain at rest. So I have this block here. The first force that you should know acting on this guy is the weight. The weight of this block is acting downwards. So let me draw it again. So this is the block here. The weight of the block is acting downwards. And the weight is given as mg, where m is the mass of the block. So there is a force, which is the weight, acting downwards. We also call it the gravitational force. But apart from this weight, there is another guy that balances the weight, which causes this particular block not to move. And what is that guy? We call it the normal force. The normal force is always perpendicular to the surface. The normal force, which of course, we also call it the normal reaction, but I like to call it normal force. So the normal force is a perpendicular force, a force that is always acting perpendicular to a surface. So as the weight of this block is acting downwards, there is a reaction. There is a normal force between the block and that surface that is opposing that weight. Now, because of the fact that these two forces balance each other, the normal force, Fn, or the normal reaction, is equal to the weight. They balance each other, and there is no external force in any way, then this body will remain at rest. That is what first law of motion is saying, that a body will remain at rest if there is no net external force. We don't have any unbalanced force acting on that particular object. Not that we don't have any force. There are forces, but these forces balance out, and there are no other unbalanced forces. But then, is it just about the fact that when a body is at rest? That is not just what first law is saying. The first law is not just saying that it is only when the body is at rest. The second part of the law is telling us that when a body is moving with constant velocity, when a body is moving, so we can also have a situation where there is motion, but then the net force is still zero. So when a body is moving with constant velocity and there is no net external force acting on it, then the body should remain in that constant velocity. It should remain in that motion. What does constant velocity imply? Constant velocity simply means that if the body is not accelerating, meaning acceleration equal to zero. Why is this? Why will acceleration be zero when velocity is constant? Remember that acceleration is actually change in velocity over time taken for that change to occur. So that means that it is actually the final velocity v minus initial velocity u over time t. So if I say velocity is constant, that means I'm saying that if the initial is, let's say, 5 meters per second, the final will also be 5 meters per second. So if I do v minus u, 5 minus 5, what will I have from here? 0. So when we say a body is moving with constant velocity, now in UTME, in JAM, they might say constant speed in a straight line. That is because speed is a scalar quantity, velocity is a vector. So before you can use speed to describe velocity, you must mention direction. So instead of saying constant velocity, you can also see it in your option as constant speed in a straight line, still the same. So when a body is moving with constant velocity, it means that there is no acceleration at that point in time, and there is no, the body will continue with that constant velocity provided we don't have any external force acting on that particular body. That is what the first law is all about. So the first law, again, is saying that if there is no net force, if the net force is zero, then there will be no acceleration. The net acceleration will also be zero, meaning that that body will remain in equilibrium. That's what we are saying. Very important. So when they say a body is in equilibrium, they are talking about the first law. If a body is in equilibrium, if the system is in equilibrium, we are simply talking about the first law of motion. And that means that it means the net force acting on the objects that we have will be equal to zero, and the acceleration is also equal to zero when the body is in equilibrium. Okay, let's progress because we have so many questions to solve. I have up to like 8 to 9 questions. I also have questions you are going to try out by yourself, which are going to be sending to me on my social media platform, and I'm going to respond to all of these questions. So we have dealt with the first law. The first law is telling me that a body will remain at rest, or it will continue with uniform velocity in a straight line unless there is a net external force acting on it. That's the first law. Now let's go to the second law very quick. Now, what is the second law saying? I know most of you will say second law is equal to F equal to ma. Well, you are partially correct. This equation here is not what the second law is saying. Yeah, I know this is what you learned in your secondary school. Yeah, you are correct. But it's just a partial, there is an assumption in this formula here. Now, the second law of motion actually states that the rate of change in the momentum. What is momentum? Momentum P. We use P to represent linear momentum of a body, and it is equal to the mass of the body times the velocity of the body. So I say linear momentum. That means that there's also angular momentum. In physics, we use capital L to represent angular momentum. We're going to talk about this when we discuss rotational motion in our proper class. Now, P equals to mv. P is the linear momentum of a body. Now, second law actually states that the rate of change of the momentum of a body, so that means when we say rate of change, we are saying that that particular quantity over time, that's rate of change. or I can say change in T, so to speak. The rate of change of this guy is actually proportional to the net force. That is, the net force acting on a body. First law is telling us that there is no net force. When there is no net force acting on the body should remain at rest, or the body should continue with constant velocity. That's the first law. Now, second law is now saying that what if there's not a net force? What will happen? There will be a change in the momentum of that body. That is, there will be a change in the velocity of the body. That is, the body will begin to accelerate when there is a net force. So second law is now saying that the rate of change of that momentum is proportional to the net force. Now, this is variation, pure variation. When we say two things are proportional to each other, it means that if this guy is increasing by an amount, this guy will also increase by that same amount. That is direct relationship. So if I have a net force of 10 Newton and it is giving me a rate of change of, let's say, what is it called here? Let's say 2, what is the unit of change in P? We are still going to do dimensional analysis and quantity. That's our first topic, quantities, units, and dimensions. A very important topic here. So if I want to break this guy down, momentum is kilogram meter per seconds, which is just mass times velocity here. Then change in time is also per seconds here, actually. So what we have, change in T is also in seconds here. So if I combine these two together, we have 2 kilogram meter per second square here. Because of course, don't forget, this is F net, which is the force. Force is measured in Newton, and Newton is same thing as kilogram meter per second square. So what are we saying? We are saying that these two guys are directly proportional to each other. If the force is 10 and the change in momentum is 2, if I increase the force to 20, then we are saying that the rate of change in momentum should also increase. That is what we are saying here. That is basically what we are saying. So the second law is saying that the net force acting on a body is directly proportional to the rate of change in the momentum of that body. So where is F equal to MA now coming from? So if I have F net equal to, of course, if I remove my proportionality sign, I'll put my equal sign and I will introduce a constant K. Then I will have change in, of course, what is P? P is MV, don't forget, that's change in MV over change in T. So I have change in MV over change in T. Now, in this situation here, we can have two cases. We can have two situations. The first situation is that we can have some questions where the mass will be constant, and it is usually the case in most of our questions. The mass is constant. So if the mass is constant, I can write this thing as K. That mass can go out of this bracket and it becomes M change in V over change in T. If the mass is constant, it can go out of the bracket here. Because of course, people that have done further math here, if you have done further mathematics here, if I say differentiate, if I say the dx of 5x squared, for instance, meaning differentiate 5x squared with respect to x, that's what it means. This 5 here is a constant, is a number. I can as well just write it as 5 the dx of x squared, meaning I can take that 5 out and focus on this x squared alone and just differentiate x squared. That's the same thing. So if the mass is constant, it can go out. Then we can have what? Km change in V over change in T. And what is change in V over change in T? Change in V over change in T is just acceleration. Now, experimentally, this K is 1. I'm going to show you how it is 1 in our regular class, so don't worry about that. So K is 1. If K is 1 and change in V over change in T is acceleration, then that means that I can write this guy as MA. That is where F net is equal to MA, this formula here. But you can see that the assumption is that mass is constant. What if mass is not constant? What will happen? We are going to see a question in this class like that. So let's progress. So in a nutshell, I can simply say that the second law is generally the net force acting on the body is equal to change in the rate of change in the momentum, or I can also say that the net force is equal to MA, provided that the mass is constant, which is usually the situation. So this is the second law. This is the second law, that when we have a net force, then we can have this situation here. Then the last guy, before we begin to solve our questions, the last law, which is the Newton's third law. This one is a popular guy. Sometimes we also call it the what's it called? There's a concept in this law called the action-reaction pair. Forces are always in pairs. Now, what is this third law all about? This third law is saying this. The first example I gave you, I have a box here. The box is resting on this surface. Let's assume I have another box on this. So I have two boxes. I have box M1, I have box M2. They are resting on each other. Now, M1 is resting on M2. That means that the weight of M1 will be acting downwards. M2 is also reacting with M1. That means that what? M2 will also what? Be acting upwards. Again, let me use another example. I will come back to the box. Let's say we have a wall and there is this guy, very stubborn boy, is here, and he made a mistake and hit his head on this wall. There's going to be an action. He's going to feel the pain. So the effect here is the action. Then there's going to be a reaction. Of course, he's going to feel the pain. The action is him hitting his head on the wall. Then he's going to feel a reaction from that, from what he has done. So there's an action and there's a reaction. Now, the higher the force he used to hit his head on the wall, the higher the reaction is going to get, the higher the pain is going to feel. That is what third law is saying. The third law is saying that action and reaction are equal and opposite. Action and reaction are equal and opposite. If there is an action, there should be an equal and opposite reaction. As you are walking on the road, there is an action between your feet and the ground. But then that is not the only thing that is occurring. There is also a reaction from the ground to your feet. If you hold a gun and you shoot the gun, let's say you go to, what's it called? You join the military at the end of the day, and you shoot a gun. Now, there's something called the recoil effect of a gun. So when you shoot a gun, it is not just the bullet that will move. This is the gun here. You shoot a gun from here, the bullet will move. That is the action. But there's going to be an effect you are going to feel. There's going to be a reaction, which is called the recoil effect on that gun. So the third law is saying that when we have an action force, there should be an equal and opposite reaction. We are going to see where these things will play out in our question. Just have these things in mind. So we have three laws of motion. The first law is also called the law of inertia. I think some of you have heard this before. The first law is also called the law of inertia. Inertia is the tendency of a body to move when it is at rest, or the reluctance of a body to move when it is at rest, or its tendency or reluctance to stop when it is already in motion. Inertia is proportional to the mass. We are saying that if I have a body sitting on this ground, the body will feel some type of reluctance to move depending on its mass. If I have a 10-kilogram body here and I have another one which is, let's say, 100 kilogram here. Now, the reluctance for this guy to move, if I apply 10, let's say I apply 20 Newton force on this and I apply the same 20 Newton force on this. This one here with the higher mass, the tendency that is going to move will be lower than this guy. So the reluctance in motion, in the change of motion, in the change of state of motion of a body is what we call inertia. That first law is also called the law of inertia. So we have the three laws. Let's just go straight to our question here. Like I said, if you have any question for me, just drop all of that for me in my... You can even drop it in the comment section. I will check and we are going to solve together on my platform. Okay, so let's look at this question. The class is solving questions very quick. You want to be very fast with your approach in solving problems. Look at this question here. You see this question in UTME and you are like, God, what is this? Now, to solve this problem, it is very easy. This question is a very simple question, provided you understand the trick. Now, what is the trick? I will show you the trick and I will show you the long way of solving it. Now, if I have two blocks, they are resting on each other. One is 10 kilogram, the other is 15 kilogram. Then there is a 50 Newton force that is acting on this block 10, only on block 10. Now, the question is to find the acceleration. So that means that we are pushing the block like this. So the acceleration will be in this direction. The acceleration is always in direction of the force, of the net force. So what would be the acceleration of the blocks? That is the question here. How do you get the acceleration of the blocks? Of course, from the second law, I already know that F equal to MA. But how am I going to solve this with just F equal to MA? If you are not in this class, what you will do when you encounter this type of question is to solve these two questions one after the other. Meaning you analyze what's it called, the two blocks. Let me erase this so I can have a clean space. So people, your coursemate or your classmate out there, the way they can solve this question is by analyzing the blocks one after the other, and you see that that is a waste of time. But I'll show you. So how do you solve this the long way? First, you will analyze the block one by one. Let's call this one M1. Let's call this M2. I will pick M1. This is M1. I will draw what we call a free body diagram. Forget about the story. A free body diagram is just a diagram that shows all the forces acting on that particular object you are considering. So we are considering M1, considering M1, considering M1. This is M1 here. What are the forces acting on M1? So there is this 50 Newton acting on it in this direction like this. So F equal to 50 in this direction. Now, this block is resting on this other block here. Don't forget what the third law says, action and reaction are equal and opposite. So there will be an action and also a reaction. So that means that there is going to be a reaction from this block, this 15 kilogram block on this 10 kilogram block. And there will also be a reaction from this 10 kilogram to this 15 as well. But because we are considering the 10 kilogram block, that means that we are going to be considering the reaction of 15 gram on it. So that means that there is a normal force acting like this. Don't forget, I said normal force is any force that is acting perpendicular to the surface. So it does not have to be on a straight line like this. It can be like this. And if I have a perpendicular line like this, this is still a normal force. So there's a normal force acting on block 10 from block 15. So let's call it the normal force N. So these are the two horizontal forces acting on this guy. I don't want to consider the vertical forces because the motion is along the horizontal. So forget about that for now. So this M1, the block, there's 50 Newton acting in this direction, and there is the reaction of 15 kilogram acting in the opposite direction. But then the acceleration is to the right. So that means that if the acceleration is to the right, that means that I can say this F here is more than the N. If the body is accelerating to the right, it means F is more than N. That means I can say the F minus the N is what will give us MA. Where is this coming from? Don't forget the law is F net equal to MA, not just F. Meaning that the net force acting on that body. So what are the forces? One is acting to the right, the other is acting to the left. So what is the net force? When two forces are in opposite directions, the net force or the resultant force will be obtained by just subtracting one from the other. So how do I find, why is it now F minus N? Why not N minus F? I did F minus N because the acceleration is to the right. So that means the acceleration must follow the direction of the force. So if the acceleration is to the right, it means I'm saying that this F is more than this N. That is so that I can have a positive value here. F minus N equals to MA. And what is F? 50 minus N equal to, what's M? 10. 10A. This is equation 1. You can see the stress. This is what you'll be doing if you are not in this class. You will do all of this. 50 minus N equals to 10A. This is equation 1. I will now go to the second block. The second block. What is happening to the second block up there? 50 Newton is not acting on that second block. The only thing acting on that second block, so this is the second block here. If this is the second block, the only thing acting on the second block is the reaction from 10 kilogram on it in this direction, meaning that just the reaction from here, that same reaction, that N is the only thing acting on the second block. So that means that for the second block, I have something like this, and we have just that normal reaction from the block 10 on that block 15 now. So since this is the only force, that 50 Newton is not acting on this 15 kilogram. It is just this guy that is causing it to move with that same acceleration. That means that in this case, it is just N equal to M2A. That means N will be equal to, what is our M2? 15, that's 15A. So our N is equal to 15A. So this is the second equation. So I have two equations. I will now do what? I will now substitute equation 1 in equation 2. What's equation 1 again? 50 minus 10a equal to 10. Sorry, what's that guy again? 50 minus n. Sorry, I don't want to go back up. The normal reaction is n. So that's, we had 50 minus n equals to 10a as the equation 1. So, and our n is now 15a. So anywhere I see n, I can put 15a here. So I have 50 minus 15a equals to 10a. And that will give us 50 equals to 25a. That means our a is 50 upon 25, and that is 2 meters per second square. That is the acceleration of the block. Then the second question is to find the normal reaction. That's our n. We already know that n is 15a from equation 2. So I can just put a as 2 here. That's 15 times 2, and that is 30 Newton normal force. And that is all. So our acceleration is 2, and the normal force is 30. But do you have that time to be solving this in your exam? Of course you don't. You don't have that time. You cannot be doing this. You have 40 seconds for a question. So why will you be going through all of this in your exam? That is why I'm here for you. So don't do this. Don't do this in your exam. Of course, you have to understand the concept, because in complex systems, when you gain admission, maybe your 100 level, you're still going to be doing dynamics again. And you can have complex systems that you can't actually use shortcuts for. You have to understand this core, core principle, the core concept. But in your exam for UTME, don't do this. What are you expected to do? Just one line, you will have your answer. This thing I did for how many lines here? Just one line, you will have the solution. And what is that one line? Let me show you. Whenever we have blocks resting on each other like this, whether it is 2, 10, 50, whatever the number is. So even though I want to make it complex, don't be scared. It's the same idea, same concept. Yeah, I have 2 blocks resting on each other. I want to find the acceleration. From the second law, F net equal to MA. Make A subject. A will be equal to F net over M. Now, what will I do? Let me make this M net as well. So I'm saying that A is equal to the F net over the M net, the net mass and the net force. What will you do to get the acceleration? The 2 blocks will move with the same acceleration. So you are just going to consider them as a single system. A single system where the force is 50, the force is 50 over, what is the sum of the masses here? 10 plus 15, 25, 50 over 25, 2 meters per second square. One go. And that's all. You don't have to waste your time. Don't waste your time. Don't waste your time. Acceleration, so even let's assume I have another block resting on this again. Let's say we have another guy, 30 kilograms resting on this. What do? Pick everything as a single system. 30 plus 10, 40, 40 plus 15, 55. What is the acceleration? The force, 50 over 55. And that's all. Meter per second square. So don't be scared when you see this type of question. Don't waste your time. So I have my acceleration. Now, how will I get the normal force? Just go to the last block. The last block. I want to find the acceleration between the normal force between the two. Go to the last block, the 15 kilogram block. Because I know that the only thing acting on it is that normal force. Just pick that mass. The normal force will be that 15 guy times your acceleration, which is 30 Newton. Easy. So don't walk through the long way. I still have so many things to show you. Don't worry. Just join us and you're going to see so many tricks on solving questions very fast. So this is how you solve the problem. Let's just go on because of our time. Let's move on to the next question. Like I said, if you have any problem, just drop it for me in my comment section at Green Notes Physics, IG, Twitter, IG, TikTok, and the likes. Now, let's look at this question here. Another diagram problem. So this is an angle here. There's an angle here. So what are we asked to find here? They said we should find the tension T1 in the diagram. If the system is in equilibrium, find the tension T1. Now, tension, we have different kinds of forces. I didn't mention this before. We have the non-contact force. We have non-contact examples, the gravitational force, the magnetic force, the electric force. They are non-contact. Sometimes we call them the field forces. They don't need to be in contact before they act, before they operate. If I throw my pen up, there is always a force that will be dragging it down. Gravitational force will always be dragging it down. It's always acting downwards. If I have an ion close to a magnet, that magnet will attract the ion to itself. That is because that ion is within what we call the magnetic field. So they don't need to be in contact before they can be a form of attraction. So they are non-contact force. Now we have contact forces too. Contact. They must be in contact before they can be an effect. An example is tension. Tension is always existing in chains, in strings, in ropes, and so on, even in springs. So if I have a rope, let's assume we have a body attached to this rope, a body of mass m. It is attached to this rope. There will be tension on this rope. How? The tension is always acting away from the point of contact. Where's the point of contact? Here. So there will be tension away from the point of contact. There will be tension T, acting away from the point of contact. We also have the normal force. It's also a contact force. We also have friction. It's also a contact force. Friction is a topic on its own we are going to discuss in our proper class. So we have all of these things. Let me erase it, but let's go back to our questions. We also have weak forces. We also have what we call the weak forces. We have what we call the nuclear force. Don't worry. Beyond getting 98 or 100 in my physics, you also learn physics properly. That's what I can assure you. It's not just about getting 98 or getting 340. You will actually know physics up to the point where you'll be able to teach someone. That is great for you. That is just me. Okay, let's go to the question. We have two ropes acting on this. We have two ropes or two strings acting on this block here, and we have to find tension T1. So one thing you should know about tension is that the tension for each rope will be different. So if I have two ropes, this guy will have his own tension. The other guy will also have its own tension. So we have rope 1 here. The tension here is T1. Don't forget, I said tension is always acting away. So there's a tension T1 acting like this. And this another rope, there's a tension T2 acting like this. Now, the key thing in this question is the fact that they said the system is in what? Equilibrium. Equilibrium should remind you of which law? First law. That is when we are dealing with equilibrium. The system is in equilibrium. Like the first one, there is a long way to this and there's a shortcut to this. Shortcut, just trig ratio, you have your answer, you move away. And there's a long way. But how can we solve it normally? Now, to solve this type of question, you need to do your analysis. You need to draw the free body diagram and remember what it means for a system to be in equilibrium. So when a system is in equilibrium, remember, we are saying that the net force acting on the system is 0. Net force is 0. But beyond this, let me break it down again. It means that the sum of the forces acting horizontally, summation Fx, sum of all the forces horizontally will be equal to 0, and sum of the forces acting on the system vertically will also be equal to 0. That is the extension of this F net equals to 0. Summation Fx will be 0, summation Fy will be equal to 0. That means that if you don't know how to do what we call resolution of vectors, you can't even use this long form here. But it's not a big deal because I'll teach you and I'll also show you the shortcut that you can use. So what are we going to do to solve this problem here? We want to find tension T1. So what do you need to do? You just need to remember the condition for equilibrium. F net equal to 0, meaning summation Fx. If I resolve all the forces to the horizontal, it must give me 0. If I resolve all the forces to the vertical, summation Fy, it must also give me 0. So this is what is happening. Draw a free body diagram. This is the 10 kilogram guy. Don't forget, the weight will always be acting downwards. The weight of this guy is acting downwards. So it has a weight W acting downwards. So I can say W equals to mg, where m is the mass. Now there is tension T1 in this direction. So there's T1 and there is T2 in this direction, T2. And let me say this is a vertical line and there is an angle 30 degree here. This is a free body diagram. So mg, what's our g? In the question they said we should use g as 10. So m is 10, g is also 10. 10 times 10 is 100. So that means the weight is 100 Newton. I want to find T1, long way. What do you need to do? Remember, summation Fx must be what? 0. Summation Fy will be 0. Now, how do you resolve? That's another big thing. But let me just go straight to the point here. Now, what is summation fx? Meaning resolve the forces horizontally. To resolve a force means that you want to place that force on a particular line. Meaning that if I say resolve a force, if I have let's say we have a force like this, and I say the force is 20 Newton. Resolve 20 Newton horizontally. It is already perfectly horizontal. So if I say what is Fx, meaning what is the horizontal component, it is just what? 20 Newton, because it is already perfectly horizontal. To resolve means place it to that particular plane. I want it to be in that particular axis. Fx, place F to the horizontal. So this guy is completely in the horizontal. That means that the horizontal component is just what? 20. But if I say what is Fy, what is the vertical component? Resolve F vertically. How do you resolve F vertically in this case? Now, when a force is completely horizontal, everything is on the horizontal. That means that it has no value in the vertical. The vertical component will just be 0. Simple. This guy is perfectly horizontal. It means the horizontal component will just be that value, 20. But what will be the vertical component? It is already perfectly horizontal. That means that the vertical component will be 0. Now, what if I have the force like this? Don't mind me, it's not slant too. Let me draw it again. Let's say this is our F equals to 30 Newton. What is Fx? Resolve this guy. Let me erase so that I can have space. So I have F to be 30 Newton. What is Fx? Resolve F horizontally. The idea again, this guy is already perfectly vertical. This vector is already perfectly vertical. So that means that if I resolve it horizontally, it is just what? 0, because it is already perfectly vertical. Horizontal component will be 0, while the vertical component will now be that 30 Newton. That's the basic thing. That's the idea. But what if it is now inclined? Look at T2. T2 is inclined at an angle 30 degrees. I don't want you to cram that your SS1 something that if you say, okay, horizontal component, cos, vertical component, sine. Don't do that in my class. I don't teach that way. There's nothing like horizontal component, cos, vertical component, sine. No. What determines whether it will be sine or cos is the angle that you are giving. Is the angle to the horizontal or to the vertical? If the angle, the vector, so let's say this is the vector. Let's say the vector is making an angle theta with the horizontal. When the vector v is making an angle with the horizontal, that is when the horizontal component will now be v cos theta. And it's not even by magic. Just look at it. Horizontal is this place. Now, if you look, and this is the vertical here, horizontal and vertical. Now, the simple way I usually teach this is this. Ask yourself this question. Remember your triangle, that anything opposite the given angle is the opposite. This is my hypotenuse here. This is my opposite because this is the angle given. That means this is the adjacent. Now, the adjacent there is my horizontal. So if I say what is Vx, what is the horizontal component? It means that you want to resolve V horizontally. Just ask yourself, what is this place to this angle? Is it opposite or adjacent? If it is opposite, it will be V sine theta. Remember sine. So car so opposite over hypotenuse. So if this place is opposite to the angle, it will be V sine theta. If it is adjacent to this angle, it will be V cos theta. Simple. So this place is actually adjacent. That means that the horizontal component will just be what? V cos theta. This place is opposite to the angle. That means that the vertical component will be V sine theta. And this is so because the angle is with the horizontal. If the angle is with the vertical, let's say this is the vector V, and it makes an angle theta with the vertical like this. So that means this is the horizontal component and this is the vertical component. Ask yourself again, what is this horizontal? What is this place to this angle? Is it opposite it or adjacent? This is opposite. That means that in this case, the horizontal component will now be what? V sine theta. While this vertical component, once this one is sine, this one will be what? V cos theta. So you can see that it's not always V cos theta for horizontal and sine theta for vertical. No, it depends on the angle you are working with. And that is the case of this question. Okay, let's be fast about this question. Let's go to the question again. So to solve, we want to find T1. Like I said, we need to remember that the system is in equilibrium, and because the system is in equilibrium, it means that summation fx, if you resolve the forces horizontally, it should give you 0, and summation fy, if you resolve the forces vertically, it should give you 0. This is the diagram again, the free body diagram. Like I said, that is what will help you to see all the forces. This is the guy, the weight is downwards, which is 100 Newton. How? 10 times 10. Weight is equal to mg. So 10 is our m. G is given in the question to be 10. Sometimes they can give you as 9.8. So use whatever you are given in your question. So this is the weight, and this is the tension T1. Why this is tension T2? T2 is making an angle of 30 degrees with this vertical here. So what do I know? Summation fx must give me 0 because the system is in equilibrium. So let's resolve the forces. How many forces do we have? We have 3 of them. 1, 2, 3. Let's start from this 100 Newton. 100 Newton is perfectly vertical. That means that if I want to resolve it horizontally, it will be what? 0, like I said, because it's already perfectly vertical and I want to resolve horizontally. Now, T1 is perfectly horizontal and it is to the left. So that means that if I resolve it, it is going to be just T1. But because it is to the left, it is what I can, when we have what we call sign conventions, when we get to, we are going to be talking about this properly in our classes. Sign convention is the use of appropriate signs for whatever you are solving, your vectors. So T1 is to the left, I can use negative, I will use negative. Anything up is positive, anything down is negative, to the right is positive, to the left is negative. So I have 0 minus T1 is minus T1 is the horizontal component of T1. It is just perfectly horizontal. Then T2 is to the right, so it will be positive. It is to the right, it's positive. But it's not perfectly horizontal like T1. So that means I need to find the horizontal component. I need to resolve it horizontally. Now, if I resolve this guy horizontally, what is this place to this angle? Opposite or adjacent? Opposite. So it will be T2 sine 30 degrees equal to 0. And that is our summation fx. That is summation fx. Let me wipe this. So what do we have from here? If I transfer the negative guy to the other side, so I have this equal to 0. That means I have T1, transfer this to the other side. T1 is just equal to T2 sine 30 degrees. Another way to see this, if you don't want to be doing this minus T1, it's still a long way, is to just remember that when we say summation fx equal to 0, it means all the forces on the left must equal to all the forces on the right. Simple. All the sum of the forces to the left must equal to sum of the forces to the right. So if you don't want to be doing minus and all of that, it just means that my T1, which is the force on the left, must equal to the component of T2 that is horizontal like this to the right. They must be equal to each other. And that's T1 equals to T2 sine 30 degrees. And so we have that first equation there. Equation 1, a waste of time. Then equation 2, we now resolve vertically. Summation fy should also be equal to 0. So let's resolve vertically. Remember, this is our diagram that we are working with. T1 is perfectly horizontal. So that means if we want to resolve it vertically, it will be 0. So what do we have here? We have 100 Newton. That one is acting downwards. So I can say it is what? Minus 100. And if you don't want to do that, you can say upward force must equal what? Downward force. But you're still going to see that it's still the same. Then T2, resolve it vertically. Horizontally is already sine. That means vertically will be cos, and it is up, so it will be plus T2 cos 30 degrees equal to 0. So what do you have from here? You can transfer your 100 to the other side. T2 cos 30 degrees will be equal to 100. So from there, you will get T2. T2 will now be 100 divided by cos 30. You have to know what cos 30 is. These are special angles. Cos 30 is same thing as sin 60 because they are complementary angles. And from that, your SS1 knowledge again, cos 30 degree is just root 3 over 2, which is 0.667. So I have 100 divided by 0.8667 like that. So you have your T2 here. You will now go back to equation 1 and put T2 because the question is to find T1. You will now go back to equation 1 and put, let me move down. You now go back to equation 1. Equation 1 is T1 equals to T2 sine 30. What is sine 30? 0.5. So T1 will be 0.5 T2. You now go back and put T2 as at the value you have here for you to get T1. Don't do this. If you are not in this class, this is the only way you will be able to solve this in the exam. But you are lucky you are in this class. So how do I solve this without doing this? This will take you like 3 minutes in your exam. This is something you can solve in less than 30 seconds. What do? This is my free body diagram. I have the 100 Newton weight. I have my tension T1. I have my tension T2. Then tension T2 is making an angle of theta here, which is 30. Theta is 30 degrees. Let me just write 30 directly. 30 degrees. There's something in physics which I'm going to show you when we resume. In vector, we call it parallel shift of vectors. We can actually shift vectors that are parallel to each other. Now, in this case now, I can form, because I'm looking for T1, that means that if this is, I can say if this is T1 here, and this is 100 here, this angle that is here, if I go back to my secondary school, there's something called alternate angles. So if this place is 30 degrees, that means this place should also be 30 degrees. Alternate angles should be equal. So if this is 30, this is also 30. So this is my T1. If this is T1, parallel shift of vectors, that means this is also T1. So in a way, I have a triangle. I have this line, this guy, and this. Let me clean this. Just look at it. Very easy. You don't need to be doing all this resolve. Be smart and very fast. I have this triangle here. So this is my 30 degrees. This is the 100 Newton. And this is my T1. Because if this is T1, parallel shift of vectors, this is also T1. I'm going to tell you what it really means in our proper class. So how do I find T1 here? This is just opposite adjacent. Opposite adjacent. And what is that? Tan. Tan 30 equal to T1 over 100. Opposite adjacent. What's T1? T1 is 100 tan 30. And that is your answer. Very easy. Without resolving, just construct a triangle from what you have by shifting your vectors. So T1 is just 100 tan 30 degrees. And what is tan 30? You can easily get your tan 30. It is a special angle. You must know all your special angles. You must know all. Tan 30 is root 3 over 3. You must know. In your math must be solid for you to excel in physics. Yes. So tan 30 is, of course, if you remember this again, if this is 30 degrees, this is 1, this is 1, this is root 3. So opposite adjacent 1 over root 3, and that is root 3 over 3. This is tan 30, root 3 over 3. So your options, you will see something like 100 root 3 over 3 Newton. Tan 30 is root 3 over 3. This is our T1. It's as easy as that. No big deal whatsoever. No big deal. So you can easily solve questions without going through the actual route if you understand these shortcuts. So I can use my knowledge of alternate angles and parallel shift of vectors to form a triangle. When I form that triangle, I can get whatever I'm asked to do for. Let's look at this final question. Our time is spent. Oh, I love this question here because this question is something that I will just look at it and pick my answer. So I want you to also be in that frame with me. That is why you are in this class. And even in all our classes, I'm going to be showing so many tricks. This type of question should not scare you. You should see these questions and be happy. Something that is so direct. Now, this is what we call an Atwood machine, a pulley system. I have two masses, mass 5 kg and the other one is 10 kg. They are both connected to the same rope on this pulley here. And the question is to find the acceleration. The shortcut, because of our time, the shortcut is this. I have shown you the shortcut before. The acceleration is just what? The net force over the net mass. Net force over net mass. But in this case, because of the fact that we don't have them resting on the table like this. If I want to analyze them, I will analyze them one by one. I will analyze the 5 kg block to see what the forces acting on this guy. I will go to the second guy, I will analyze as well before I can now say, okay, I want to find the acceleration here. But with this shortcut, you can easily get your acceleration. Maybe let me just show you the normal way. The normal way is, okay, you go to the 5 kg. What are the forces acting on that 5 kg? If this is a 5 kg guy, remember the weight is acting downwards, weight mg. And this is a rope, so that means there will be tension in this rope, always acting away. So there's tension in this rope. It is straight to tension T. Now, look at these two blocks. One is 10 kg, one is 5 kg. And they are connected to the same rope. One should be moving down, one should be moving up. It's just common sense. Because this guy is heavier than this. The 10 kg should go down, should be accelerating downwards, while this guy should be going upwards. So if that is the case, we follow the direction of the acceleration and we take it as positive. So for this 5 kg block that I'm considering here, the acceleration is upward. It is going up. Why is it going up? Because it is smaller than this other guy. So if this guy is going down, this one will be going up. So that means that if the acceleration is upward, it means that I can say the tension T is more than the weight mg. So that means I can say T minus mg is equal to ma, the same Newton's second law. And that's T minus, what's m? 5. Let's take J as 10. So 10 minus 50 equal to 5a. So I have this as my equation 1. I will go to the second block and say, okay, if this is the second block here, this is the weight mg, 10 times 10, that's 100 Newton, and the tension is upwards as well. The tension is upwards as well. So we have tension T here. Because this guy is going down, that means I can say that means the 100 Newton is more than the tension. So that means 100 minus T is equal to ma. What's our m in this case? 10. That's 10a. So I have 100 minus T equal to 10a, while here I have T minus 50 equal to ma. If I come back to this equation here, let me make T subject. T will be 5a plus 50. So anyway, I see T in this equation 2, or let me make T subject here too. That's 100 minus 10a equal to T. So 100 minus 10a equal to T, and T equal to 5a plus 50. I can equate the two together because T is equal to this and T is also equal to that other guy. So if I equate the two together, that means 5a plus 50 equals to 100 minus 10a. So collect like terms. 5a is here. Let minus 10a go to the other side. That's plus 10a equal to 100 minus 50. That means I have 15a equals to 50. So what's my a? 50 over 15 meter per second square. That's the acceleration. I don't have to do this. What will I do instead? This is what I will do. A is the net force over net mass. What is the net force in this case? The net force in this case will now be the difference between the masses times g, meaning 10 minus 5 times g, which is 10, over, what's the net mass? 15. What do we have here? 10 minus 5, 5 times 10, 50, over 15 meter per second square. Easily. Net force over net mass. But in this case of the Atwood machine, you subtract the masses. You subtract the masses in this case. Because this guy is acting downwards, this guy is also acting downwards. So you subtract the masses for you to, that is their weight, to get the net force. And that is all. So the beauty of UTME is the beauty of it all is that you see a question and you understand that I don't have to be using, so I don't have to be following the normal route to solve that question. There are so many tricks. There are so many shortcuts that can be used to solve a question, but you just need to understand the concept. And that is why I'm showing you the long method before even showing you the shortcut to solve that particular question. So let me stop here for today. I want to believe that you enjoyed the class. I still have questions here. So this is what I would do for you guys. So I want you guys to engage me on my social media platforms. I'm going to be posting. I'll be solving these questions. Look at this. Look at this interesting one. I'll be solving all of these questions on my platform from today or tomorrow, and I want you to engage. And I also have questions for you to also attempt. If you have any topic you want me to actually solve, just let me know in the comment section there. Just send it to me. I'm going to do justice to everything. The class continues tomorrow, yeah, and tomorrow we are going to see something interesting. We are going to see optics. You are going to see the tricks in refraction, in reflection of light, something that you are not even aware of. So don't miss that class for anything at all. And do remember that this is just a free class. It's just a class for you to understand that, oh, we are ready for business. We are ready for you guys. The main class that will last for 3 to 4 months is starting very, very soon. So just go to our website for you to register. Just register. This is so affordable, trust me, and you have the best tutors here. So don't forget, my name is Green, and I'm so happy to teach you guys today. And I see you the next time. Take care. Bye.